2.1, part 2, day 2, part B, however you want to phrase it. The alternative definition of a derivative. So there's a different way to do it, hence the name alternative, but this one is for the derivative slope at a particular point. So Friday, the definition, the full definition, gives you the derivative at x or at t. So that's a more generic definition. This definition is only going to give it to us at one particular point. But it follows kind of the same rules. So let's draw another picture. And let's say we want the point at x equals c. This is going to work really similar to what we did on Friday. So I got c and f of c, that's one point. X and f of x, that's another point. There's my secant line. That slope's not really what I want. Right? The slope that I want is down here at c. I want a tangent line, not a secant line. But just like Friday, I can't find the slope at one point. At least with algebra, I can't do that because I need 2 points. We want to find the slope at c. That's what we're looking for, or the derivative, so f prime at c. Well, just like we did on Friday, we'll start with the secant line slope and use algebra. So if you remember your algebra rules, the definition of a derivative comes from algebra. y2 minus y1 over x2 minus x1. But instead of h going to 0, we're going to have x going to c. As x approaches c, we'll shrink that distance and we'll bring the secant line in line with the tangent line. So f prime at c, it's going to be that same slope formula, but we want the limit as x approaches c. So that's the alternative form of a definition of a derivative. So there's two definitions. You have to know both of them. You have to know, all the limits. You have to know both of them. You have to be able to use both of them. And the big difference is this tells you that slope at a particular point. As opposed to the other format tells you the slope at any point. You can plug in an x value after you do the other definition. With this definition, you're going to get an answer. And so it's helpful, but it's only helpful once, I guess is one way to say it. In some ways, this one's easier, but it only gives you one answer. The other definition is more difficult, but it allows you to find the slope anywhere. So we'll tell you which one we want to use. So you don't have to figure out which one should I use. We'll basically prompt you to use the right one. All right. Yeah, maybe I should have done this first, but average rate of change. Average rate of change. Well, rate of change is another word for slope, right? Like how steep something is, how fast you're going up the mountain, how steep is the mountain, what's the rate of change. The average rate of change, though, means don't use a derivative, use algebra. So this isn't a new concept, it's new words for a concept you already know. Right? You know how to find algebra slope. You just haven't called it average rate of change before. So let's find the average rate of change on 1 to 3 given this table of values. So x's go 1, 2, 3, 4. The y's go 4, 6, 9, 16. So rate of change means slope. Average means don't use calculus. Well, we couldn't use calculus anyway because we just have points. So really we just want the algebra slope. So this is just y2 minus y1 over x2 minus x1. There's extra information in here, so be careful what we're looking at. So from 1 to 3, 9 minus 4 over 3 minus 1, so 5 halves. So that's not a new idea, right? You know how to do slope. It's just maybe a new name for it, average rate of change. As opposed to instantaneous, let's see if I can spell that right, instantaneous rate of change. So average rate of change is algebra, that's like a secant line. Instantaneous rate of change, that means we want the slope of a tangent line. That means we're going to need to use calculus to find the slope. But using calculus to find slope, that means use a derivative. So rate of change means slope, but average rate of change means use your algebra skills. Instantaneous rate of change, or tangent line, means use your calculus skills. So most of our work is going to be in the calculus realm because you did average rate of change, 100 times in 8th grade algebra, right? So you know how to do that. It's just we put a different name on it. And we should use average rate of change earlier on so it's not confusing later, but most people don't. Average rate of change means algebra rate of change. Instantaneous rate of change means calculus rate of change. Calculus slope, therefore derivative. Okay, let's do some examples. Find the slope of a tangent line to y equals 3x squared plus 2x minus 1. Slope of a tangent line. So secant line won't work. Algebra is not going to work. We need to use our calculus for whatever the rest of this problem is. Slope of a tangent line to that graph at x equals 2 using the alternative definition. Okay, I'm going to rewrite the alternative definition because there's things I got to plug into that. So it's still a slope formula. It's just a little bit easier. F of x minus f of c over x minus c as x gets closer to c. That's the derivative of f at a particular point. So not at x, but at a particular point. So for us, we're looking at the point x equals 2. So I need f of x. Well, we got f of x. I need f of c, so I need f of 2. So I'll plug 2 in to get f of 2. Let's see, 2 squared is 4, times 3 is 12, plus 4 minus 1. So f of 2 then is 15. So now I'm ready to plug things in. Maybe I should rewrite this definition specific to this problem. F prime at 2 for x equals 2 is the limit. So c is 2 as x gets closer to 2. F of x, 3x squared plus 2x minus 1 minus f of 2, f of 2 is 15. All over x minus 2. You okay where all those pieces came from? F of 2, f of x, and x minus 2 at the bottom. As almost always, not quite always, but almost always, if you try to substitute first, it doesn't work. So let's see if we can clean up the top here. 3x squared plus 2x minus 16 all over x minus 2. Boy, it would sure be nice if that factored, and especially be nice if it factored with an x minus 2, because then it would cancel. So I'm just going to, I should have said pencil in, but I'm going to pin in x minus 2 and hope that that's one of the factors. So it would have to be 3x to make 3x squared. It would have to be 8 over here to make 16. And it would need to be positive 8. Let's see, it's the double smiley face. I guess it's the double frowny face if you got to go upside down here. 8x minus 6x is 2x. So I feel good about my factoring. I feel really good because it cancels. They're all rigged to work this way. Okay, this isn't like, oh, that was kind of cute. No, it's rigged to work that way. They're going to work. Now I can try to substitute 2. So 6 plus 8 is 14. So my slope at 2 of that graph is 14. Tomorrow we'll learn the shortcut. But for today, we're still going the long way around. Let's do another one of these. Example, whatever example we're on now, 3, I think. Find the equation of a tangent line. I'll pause there for a second. Equation of a tangent line. So not just the slope. I mean, we'll have to find the slope, but then use that slope to write the equation of a tangent line. I think I warned you on Friday that we're doing this a lot, writing tangent lines. 2 f of x equals square root of x plus 1 at x equals 2 using the alternative definition, the alternative form of the definition. So that means f prime at 2 using the alternative form f of x minus f of 2 over x minus 2. Right? The argument of the limit is always an algebra thing. Right? It's an algebra slope. And we want that as x gets closer to 2. So let's see what we know here. We know f of x. X and 2 are fine. I need to find f of 2. Square root of 2 plus 1. Be the square root of 3. So limit as x approaches 2. So now I'm just plugging in my pieces here. F of x is square root of x plus 1 minus f of 2 is square root of 3 all over x minus 2. And that will tell me the slope, or the derivative, means the same thing, slope, the derivative, at 2. That one was nearly identical to one of the ones on your test. I think I left that one on the test. What number that was. And how close it was. So not identical, but number 12 on one form, the square roots. So how do I fix that? What do I look back at your test or think back? What do we do to fix that square root thing? Conjugate. Multiply by the conjugate. Square root of x plus 1 plus, that's the conjugate part of it, square root of 3. Square root of x plus 1 plus square root of 3. By the way, I think we're done with the calculus part of this problem. Now we've got a whole bunch of algebra left to do. So let's FOIL the top. We get x plus 1. Now when we O and I a FOIL, when we OI the FOIL, they should cancel out because we multiply by a conjugate. So if you want to write it out, you can, or you can just look at it and see that minus all that stuff plus all that stuff should go away, and that leaves minus root 3 times root 3 would be 3. And then in the bottom, you might remember that we don't want to multiply out the bottom because we want the bottom to cancel for us. And it does. Again, magic happens because the top is x minus 2. That's x minus 2. So now we can substitute. We get 1 over root 3 plus root 3. Some of you left that as an answer, and that is okay. That is an okay answer. You can leave that. Most of you that simplified got it right, but there were a few people, I don't know if they were in here, but across all my calculus classes that said that that was equal to square root of 6. Yes, you can laugh at them. I can't, because that'd be wrong, but if you want to, I'll leave that up to you. I'm going to go ahead and simplify it because I'm not through with this problem. I don't have to, but I don't want to keep writing 1 over root 3 plus root 3. So that is f prime at 2. That means that's the slope of the tangent line at x equals 2. That's a lot to, I don't have to write all that, but you need to understand what we just found. Right? In most problems, especially in this unit, there's two things going on. Do you understand, like, big picture what you're finding? And then the details, do you understand how to do it? And so we want you to get to where you understand both of those things. The struggle is some people will get the process down, but they don't really understand what they did. Like, their algebra is great, but they don't know what they just found. Other people understand what they're doing. Their algebra, though, lets them down, and they can't get to the right answer. We need you to have both. Understanding the concept of what you found, but also understanding the details of how to get there. All right, so a tangent line, or any line, is y minus y1 m times x minus x1. So I need a slope and a point. We just found the slope. That's what all that was for. So I need a point. Did it give me the point? Gave me the x value of the point. But I need the y value of the point. Oh, but it gave me that. Well, it didn't give me that. I already found it, though. F of 2 is root 3. Remember, that means there's a point 2, comma, root 3. Again, the concept of what did you find here, what does that mean? Well, that means 2 root 3 is a point on the graph. So I've got a point, I got a slope. So y minus root 3 equals 1 over 2 root 3 times x minus 2. That's an ugly looking line, but it's a line and we're good. And again, square roots in the bottom, hey, we're in calculus. We got bigger things to worry about than fixing square roots on the bottom. So we're okay with that. Leave that alone. Again, we got bigger things to worry about than that. All right, so today's assignment is still page 103, so we're still in the same section. The book lumps all this together, but that's a lot to do at once. Page 103, 65 to 79 odd. So if you haven't done the previous 103, you've got 2 from 103 you have to do, and now you've got to also keep them separate in your brain, the original definition and then the alternative form of the definition, and how to do each one and when to do each one. So that's a lot to keep up with. The good news is, sorry for you people watching on video, the good news is tomorrow is a good day to watch the video lesson, because tomorrow is the power rule. That's the shortcut rule. So tomorrow you're going to be mad at me because you're going to be, why are we doing all this definition business? Why didn't we skip to the power rule? Well, you got to know the definition. So tomorrow's a little bit of an easier lesson. The power rule tomorrow.